In our next exponent property lesson, we're going to be taking a look at something called the power of powers property. So we've talked about those words and how the names of these properties can help us understand what's going on. So when we're saying a power, we're talking about exponents. And so basically what this title is telling us is that we're going to be looking at exponents that are on exponents. So what it's going to look like is we're going to have some things that come in parentheses. So we maybe are going to have something like x to the third, and that's going to be raised to the second power. And so what we want to do is think about what that actually would look like expanded out. So if we go from the outside of the problem in, we're saying that something being raised to the second power means it's being multiplied by itself. So really what that means is we're doing x to the third power times itself, which is x to the third power. And so we've reviewed this idea then that when we're multiplying like bases, that we could take that shortcut that tells us we could add the exponents together. And so what that means is we would really get an answer of x to the sixth power. So what we want to do is think about how we could go from here over to here, skipping all of that middle stuff. And what we're going to notice is that if we take these two exponents, when we apply an exponent to an exponent, we can keep that base and we can multiply the exponents. So that's our next rule. So when raising a power to another power, so an exponent on an exponent, we're going to keep the base the same. There's only one base in this problem, and we're going to multiply those exponents together. And the reason that we can do that is this pattern that we've shown up here. Always remember at the end to simplify. Make sure you get rid of any negative exponents. So our first example, we have 3 to the second being raised to the fourth power. And so our rule says to keep the base, which is 3, and then we're going to multiply the exponents. And so we're going to do 2 times 4, which gives us 3 to the 8th power. Here we have 2 as our base, and we're going to multiply negative 3 times 3. Just remember your rules for integers. So what we're going to do here is we're going to multiply negative times a positive, which is going to give us a negative 9. And then we have to simplify because we can't leave negative exponents. So that starts out on the top, which means it's going to have to move to the bottom, and our final answer would be 1 over 2 to the 9th power. Okay, here we would keep our base of x. We would multiply 4 times negative 2, and that's going to give us x to the negative 8th, which we then would simplify to 1 over x to the 8th. And here we have an m to the third being raised to the 0. So m to the 3 times 0. Well, anything times 0 is 0, so we really have m to the 0 power. And we know that anything to the 0 power equals 1. Here we would do x to the negative 2 times negative 1. And when we do a negative times a negative, we get a positive. So we have x to the second. Okay, now we're going to get a little bigger. Notice inside this first set of parentheses we have something that we could really kind of break up and expand out. So we really have 3 times g to the negative 4th being raised to the second. And so what we want to do is we want to remember that that 3 is separate, and so this exponent out here, we have to apply that to all of those exponents. And when we don't see an exponent, there's really a 1. So that would be 3 to the 2 times 1, which gives me 2, and then g to the negative 8th, and then over here we're going to multiply, and we're going to get g to the 6th, and that's all stuff that's being multiplied together. So now we have another rule that we could go back to where we learned about those like bases. So we notice that we have g's here and here. So before we worry about simplifying, we're first going to combine those together using our product of powers property. So my 3 to the second stays, and now for my g's I'm going to add my negative 8 plus 6, and that gives me negative 2. Now it's time to simplify. So I'm going to have 3 to the second over g to the second. So as you're going through, remember at the end that you have to simplify all of your work. That means you can have no negative exponents or 0 exponents in your answer.